Hello guys, welcome to the DMS online school. In this video we are going to consider the last part of our revision from the topic in mathematics called menstruation. So on this topic we have this question which came in 2016 school certificate ordinary level. This was question 9. The question was B. The question reads, the cross section of a rectangular tank measures 1.2 meters by 0.9 meters if it contains fuel to a depth of 10 centimeters. Find the number of liters of fuel. Find the number of liters of fuel in the tank. So 1 meter cubed is equal to 100 or 1000 liters. Then C, a cone has a perpendicular height of 12 centimeters and slant height of 13 centimeters. Calculate its total surface area. Take pi equals to 3.142. Okay, let's go straight into the answering of this question. So let's look at the solutions. So now let's start first of all analyzing the question. So this is B, sorry, this was actually B. So we were told that we have a cross section of a rectangular tank. So we have a rectangular tank. So let us look at this rectangular tank which they are saying we have. So we have a rectangular tank. Let me draw something similar to a rectangular tank. Okay, so I'm going to use this one to demonstrate a rectangular tank. Okay, so I'll use this one as a demonstration of a rectangular tank so that you understand. So we assume it's a tank like this. Okay, so this is a tank. Yeah, so this is a rectangular tank, measures 1.2 meters by 0.9. So it means there's length and breadth. So length, it is this one. So this one is length, which is 1.2 meters, and then breadth is 0.9 meters. So this part is 0.9 meters. So this part is length, then this part is breadth. Then they're saying if it contains fuel to a depth is the same as height. Okay, so depth is height here. Okay, so height, which is the same as height here. So depth of what? Of 10 centimeters. So depth is 10 centimeters. So this is where the trick part of the question was. They had to put 0.9 meters, then they had to put 1.2 meters, then they had to put 10 centimeters. So if units are not matching, you have to convert them so that they match. So for you, convert this one by dividing it by 100 so that it becomes 0.1 meters, so that you have meters throughout. So now from there they say find the number of liters of fuel in the tank, because they're saying if it contains fuel to a depth of 10 centimeters, find the number of liters of fuel in the tank. So they want number of fuel of liters. So number of liters is similar to volume. So they are asking to find the volume. So we are looking for what? For volume now. So in every question, know what you are looking for. We are looking for volume. Okay, so it means that the whole of this tank here was full of fuel, considering that we are using 10 centimeters, which is 0.1 meters as the height or depth. So we now have to look at the formula for the volume. Volume is found by multiplying breadth times, length times breadth times height. Okay, so here we already have everything in place. Our length is 1.2, so we should put 1.2 times breadth is 0.9, then times, then we have a height, it is 0.1. So we will multiply everything. So when we multiply everything, our answer will be 0.108. Then this one will be meters cubed as the volume. Now remember, this volume they are saying should be in liters. So that's why they said 1 cubic meters is equal to 1000 liters. So finding this volume will convert to say, okay, now that 1 cubic meters 1 cubic meters is equal to 1000 liters. Okay, then we'll say, how about this one we have found? It will be how many liters? So say, how about 0.108 meter cubed? It will be how many liters? Or put x. That is to say unknown. Then we will cross multiply. We'll say 1 times x, it will be x equals, then 0.108 times 1000. If you multiply like 0.108 times 1000, you are going to get x as 108 liters. So this will be our answer. So we go to B. The same. A cone has a perpendicular height of 12 centimeters and slant height of 13 centimeters. Calculate its total surface area. So we have a cone. So we will go to B, where we will look at cone. Is this B or C? This is now our C. So this is our C. So our C is saying we do what? We calculate total surface area. So we are going to calculate total surface area. So how do we find total surface area? So we are now going to find total surface area. Which is sometimes abbreviated as TSA, total surface area. Now, of what? Total surface area of a cone. So this one has a formula like total surface area of a cone is equal to, so we'll have base area, we'll call base area plus what they call curved surface area. So this is our formula. So our formula, yes. So now we are going to draw the cone so that you understand what a cone is. So a cone, let me pick something to use to show to you what a cone is like. So a cone is like this. Let me just do like this. Yeah, so this is the cone. So the cone has a height from the center of the base, then it has also radius. This is the radius. So the height is perpendicular, so we can put a right angle symbol there. So now if we get back to the question, they have said that they have given us a perpendicular height which is 12 centimeters and then slant height which is 13 centimeters. So now perpendicular height is this one, 12 centimeters, this one here, 12 centimeters. Then slant height is this one, 13 centimeters. This one here is slant height, then this one is perpendicular height. Okay, so we need now to find the curved surface area. So curved surface area, this is in word the formula. So in symbol, total surface area is equal to base area is here, is given by pi r squared. This is the base area. Then plus, to find curved surface area, you say pi r times L. L is slant height. So this slant height here gives us this L here. So when we look at what we have been provided, we have been given pi, okay? We are given pi as 3.142. Then slant is equal to 13 centimeters. Now, in our formula, we need to look for radius. Do we have radius? No. So radius is what is missing in our formula. Now, is there a way of finding radius? Yes, there is a way of finding radius, which is using Pythagoras theorem. So we can use Pythagoras theorem here. So now, Pythagoras theorem says, Pythagoras theorem works with a right angled triangle. When you look at this, we have a right angled triangle here, where we have the longest side, the hypotenuse, then the height, which is the opposite, then the base, this one is the radius. So this one, the radius, is the adjacent. So since we are looking at r, their radius, we can use this formula, which says the adjacent, which is r squared, plus the opposite, which is 12 squared, is equal to, it should give us what? It should give us the hypotenuse, which is 13 squared. So what are we going to do? We will say, okay, r squared is equal plus 12 squared, it will be 144 equals, then 13 squared should be 169. Okay, if not mistaken. So now what we are going to do is this. We shall now make r the subject of the formula. So to make r the subject of the formula, r will remain this side squared, then to be equal to 169. Then 144 will cross the other side. Since it is positive, when it crosses, it becomes negative 144. So say r squared is equal to, so we will now do this. Let me do this using the calculator I have. So we'll say, let me first prove 13. Okay, yeah. So now we'll say 169 minus 144, which will give us 25. Now, since we are looking for r, not r squared, to remain with r, we'll square root this so that we get rid of the square. Even this side we square root. So the square and the square root, they'll go. Will remain with r is equal to square root of 25 will be 5. Now that we have found r, we can now go ahead. Now r here has become 5. So we have everything 5 centimeters. So we have everything now to find the answer. So say, okay, total surface area now is going to be equal to, we can in fact factor out what is common. Pi is common here and here. Factor out your formula. Then r is common here, so factor it out. Then open brackets. Here you have factored out r, pi and r, so you have remained with 1r plus, here pi and r, they are all gone, you have remained with l, close brackets. So this is the formula for total surface area for a cone. So you say, okay, equals, then your pi, you put 3.142 times radius, which is 5. Then you say open brackets, you have also r radius 5 plus slant height, which is 13. You put your 13 there, you close brackets, then you say equals. So let me try to multiply 3.142 times 5. I'm getting like 15.71. Then I'll say times what is inside the bracket. So I'll say 5 plus 13, I'll get 18. So now we'll multiply. So say 15.71 times 18. So we'll get 282.78. So this will be the total surface area. So the units for area are centimeter square. You put a square there. So this is the solution to this question. Okay. Then we are done with the two parts of this question. So then we will go to the next part. Now the next question is this one here, which we can consider because in our revision we didn't consider this one. Now in case you come across such a question, this is how you can handle it. So let us just wait a minute, connecting the power, the charger to my laptop. So now here we have question 7b, which says the diagram below shows a cone. The shaded part is the thickness of the cone. The internal volume is 34,650 cubic centimeters. The internal base area is 3,850 cubic or 50 square centimeters. Take pi to be 3.142. So what we have is a cone. You can see this is a cone with this thickness which they have shaded. Then it has the radius r here and height there. Okay, so very important that you take note of those. Then they're saying calculate the internal height, that height from the base to the top, that one, and radius r, and this radius r here. So what have we been given which will enable us to find this answer? So we have been given volume. Volume as 34,650 cubic centimeters. And we have been also given area is equal to this one here, 3,850 square centimeters. Now, these are the values they have only given us, yet they're asking us to find height and the radius. It means that internal height and radius are hidden in these values. How? First of all, let us dissect, okay, the actual formula for finding volume of a cone and the actual formula for finding area of the base. So when finding the volume of the cone we said is equal to 1 over 3 then pi r squared times what? Times height. So you have seen that in the formula for the volume, there's already r, this one, and height, that one. But again, we know that this part here is the area. Okay, so I can tell you again to say, okay, area also, let's ignore that part which I've told you. I think it will confuse you. Let's just go to area. We also know that we have been given area. Area, base area, which they have given us, this one here, is found by pi r squared. So we can see that in area we can find the r, and then in volume we can find the height. Okay, so what are we going to do now? We will find first height. So to find height, let's find first the height. So solutions, so we want to find one height. So to find height, we will use volume. Volume is equal to 1 over 3 pi r squared height. So what we are going to do is to ensure that we we make in fact in this one, before we can find height, we need to find radius. So we will not start with, because let me first make h height the subject of the formula. To do so, we will just say over 1 here, then cross multiply. So say 1 times everything here will get pi r squared height, then volume times 3, it is going to be equal to 3 times volume. So to get h, we divide by pi r squared, even here we'll say divided by pi r squared. So this one and this one will go, which is actually area. Okay, so remain with H is equal to 3 volume over pi r squared. Okay, so it is now moving well. I've seen that it is moving well. So you have seen that pi r squared is area. So it means that our formula is just going to be like equal to 3 times v over area. This is area, height. So having known that, we shall just get the values for volume. Volume already 34,650. So say okay, 34,650. Before I write this one, before I write that one, let me write 3. So we are saying 3 times 34,650 over area. Area is here, which is 3850. 3850. So say 3850. So we'll say equals. Now let us do the multiplication. It's just that I'm doing it on my phone. I'll say 3 times 34,650 equals that answer found divided by 3850. So I found that height is 27. I say okay, height is 27 centimeters. You put the units. So we have found height, then we go to radius. Let's find the radius. Radius, this one here. Radius is directly related to area. So we will say to find the radius, radius is related to area. So say pi r squared is equal to area. I've decided to start like that so that I'll quickly find the subject of the formula. To find r, the subject of the formula, we'll divide by pi, even this side by pi. Okay, so that this and this will go. So we'll have radius squared is equal to area over pi. Now to find radius, not radius squared, or square root this side and also square root this side, so that this and that will go. So we'll say okay, now radius is equal to area over what? Over pi. So we'll put like that. You've seen? So now we are going to substitute area. We'll say area is equal to 3850 over pi 3.142, then square root, then say equals. So we divide, I'm just using my calculator here, 3850 divided by 3.142, I get my answer there. So if I square root my answer, Okay, let me just do this at once. Let me say square root of open brackets 3850 divided by 3.142 close brackets answer. So I'm getting 35 point something and other values, but the closest is just 35. 35 centimeters is our radius. So we will now move to Roman numeral 2. They are saying given that the cone is 0.7 centimeters thick, calculate the external volume of the cone. They are saying given that this is the thickness of the cone here, what would be the external volume considering the outside dimensions? So for us to know the volume, we should know the actual diameter from here, radius from here up to the end here, and height from here or from there up to the end here. So now those dimensions, that height, we will call it capital height, and that radius we will call it capital radius. So capital radius will be equal to small letter radius plus the thickness. We'll just add the thickness, which is 0.7. Now remember, radius has been found to be 35. So 35 plus 0.7, it will give us 35.7 centimeters. That will be our radius. So to find the capital H, this is what we are going to do. So radius, remember, it is 35.7. So we are on Roman numeral 2, where we want to find the external volume of a cone, or of the cone that we are given. So I said we will use capital R and capital H. So volume, remember, is equal to 1/3 by, now R, will use this one, R squared and H. So we have determined R squared, capital R, as 35.7 centimeters. Now we are remaining with capital H. So capital H is unknown. So what we are going to do is to use ratios to find the capital H. So we will use ratios. So what we are going to do is this. Let me first of all come to the diagram and tell you how it is. So we'll say the ratio between two radiuses. We have two radiuses. One, the external from here to the last part there. That is the external radius we are talking about. Then the height is from here down up to there. That is H. So these, they work in ratios. So now, because they are sharing the same center, the same, for example, apex or top, we will use the ratios which say small letter radius over capital radius is equal to small height or over large height. So that's how it is going to be. So we shall first find that height. So small letter radius, we already found it as what? As 35. Then capital radius is 35.7. Then we want the h. Okay. So let us just scroll down a little bit. So I said first let's find h. So say r over capital R is equal to small letter h over capital H. Then I'll make capital H the subject of the formula. So we'll cross multiply. So say R times H, it will be R H equals, then R times H, it will be capital R and H there. So to get capital H, we'll divide by small letter r, also here by small letter r, so that that one goes. So we have H is equal to capital R H over small letter r. So we substitute. So say equals capital R, I said it was 35.7, 35.7 times height. Height was found to be here like 27, I think. Yes, height is 27 here. So we'll come back and say 27. So say 27. Sorry, the app is almost like freezing. Over small letter radius was 35. So now I'm going to multiply these. So I'll just use my calculator where I'll say 35.7 times 27 equals, then that answer divided by 35, I'm getting 27.54. So 27.54 centimeters. So this is the capital. And now finding that one, now we shall say, okay, we now know h. H as in 27.54. Now after knowing that, now I can just solve for the volume. So in solving for the volume, I'll substitute. I'll say volume is equal to now 1 over 3 times pi 3.142 times r, capital R, which is 35.7 squared, then times height, which is 27.54. So we'll say equals. So let me just do this one. I'll say 3.142 times 35.7 to power 2 times 27 0.54 equals that answer I'm getting divided by 3. I'm getting the answer like 36,760.83. So this will be our volume in centimeter cubed. So let me see if you have answered all the questions, because these are the questions that I wanted to revise on this topic before we can start now earth geometry. Yeah, so this is where we end today with this revision. I'll send you the questions in the group. Okay, so for now, bye and see you in the next revision.